Today, our topic is graphical method in operations research. So, how can we solve the optimization problems with the graphical method? Yes, the graphical method has its own procedure. In first step of that, consider all the constraints taking the equality relationship. For example, if I consider x less than or equal to 40 means I consider that equation into x is equal to 40. And then second step is represent the constraints graphically as like this diagram. We can represent the constraint equation with the graphically. After that, mark the solution space in the graph satisfying all the constraints as like this gray region. Likewise, we can fix the or mark the solution space. From this solution space, we can identify the arbitrary value of z. Let's see how can we practically solve the problem. We will discuss with this problem. The problem is solve the following entity by graphical method. Objective function is maximization of z is equal to 3x plus 5y. Subject to the constraints x less than or equal to 40, y less than or equal to 30, x plus y less than or equal to 60, x comma y greater than or equal to 0. In our previous video, how can we form the linear programming problem? Likewise, I explained similar to same. We can generate the constraint equation like this. After that, the solution. So the second step of graphical method is represent the constraints graphically. First step is consider all the constraints taking the equality relationship. According to this, I can convert these constraint equations x less than or equal to 40 into x is equal to 40. Likewise, I change the second equation y less than or equal to 30. I convert that it into y equal to 30. Then third equation is x plus y is equal to 60. Here I didn't get any x value and y value, x comma y. Likewise, I can't get from this equation. For the reason I put x is equal to 0 in equation 3. From this I can get the point of y is equal to 60. And then y is equal to 0. I put y is equal to 0 in the same equation 3, I can get the x value as like x equal to 0. So from equation 3, I get the two arbitrary points which are x, y is 0 comma 60 and 60 comma 0. Likewise, I got the 2 points. So how can we solve the problem with the graphical sheet? I can represent the lines with respect to graphical sheet according to our collected equations from this solving procedure. Here x is equal to 40. What is meant by x is equal to 40? How can I represent? Yes, in x-axis I mark x is equal to 40 4 units. In that direction there is no y value, so that I can draw the line parallel to y-axis, so that I can get the line as like for equation 1 is x is equal to 40. Similar to same equation 2, I consider the equation 2 here y is equal to 30 available, so I mark 3 units along x-axis, so y-axis, so I can get the 30 from y-axis. So parallel to x-axis I can draw the line with respect to equation 2, that is y is equal to 30, so that I got the lines from graph sheet with respect to equation 1 and equation 2. And what can we do for equation 3? Because here there are two terms available, which is x and y. Those things are available, so that I convert that equation it into two points, two arbitrary points. From x is I put x equal to 0 and y is equal to 0. Likewise, I put that equation, I got 2 points. So I represent to the 2 points with this graphical sheet, which is 60 comma 0 0 comma 60. So in this equation I can mark the 60 comma 0 here and 0 comma 60 in here, so that I connect those 2 points. I can get one inclined line with respect to 0 comma 60 and 60 comma 0. So now I can move. What is the solution space? I can want to identify the solution space. Here after y direction there is intersection available. After this equation 2 line there is intersection available, so that I can find the solution space as like where the intersection are available, so I omit all the things. So where the solution space available, yes, if I draw the hatching in below the y-axis and behind the x-axis line, which is equation 1, and below the x-axis line I got the solution space here. After that there is another one inclined line available. From this also I avoid all the intersections so that the solution space available within this area. From this I can mark the balance area from here, A, B, C, and then D. After that finally I may got E. So solution space is around A, B, C, D and E. So every point where the final solution space point I got from A is getting from graphical sheet I like 0 comma 30, and B 30 comma 30, and C 40 comma 20. According to our graphical sheet we can get the point likewise. After that D point 40 comma 0. In x-axis there is 40, in y-axis 0, and then E in x-axis 0, y-axis 0. So that likewise I can collect all the points which are lying between the solution space area. So A 0 comma 30, I substitute this it into objective function equation. Objective function equation is z is equal to 3x plus 5y. According to our problem, objective function is maximization of z is equal to 3x plus 5y. So that I substitute the first value, a value it into that objective function equation, I got 150. If I substitute 3 into x as 0, 5 into y as 30, so that I can get 150. Similar to same zb, I will find another value which is zb. Here 3 into 30 plus 5 into 30, likewise I got 240 because I got the B point from this solution space as like 30 comma 30, so that I can get 240 from B point, so that which is called as ZB, and then ZC I find similar to same as the B point. So 40 comma 20 I substitute the values 40 rather than x and 20 for replacement of y, so I can get 220, and then I substitute D corresponding value into the objective function equation. Here I got 3 into 40, 3 into 40 plus 5 into 20, so that I can get 220, and then the D point is 3 into 40 plus 5 into 0, so that I got 120. E point Z is equal to 3 into 0, 5 into 0, so E point I can get 0. Here I compare all the 5 point solution A, B, C, D, E. From this, which one is maximum? The objective function maximum value I obtained from B point, so that this 240 is called as optimal value, which is best value, because our function objective function is maximization. So maximization of z is equal to 240 can get collected from B point. So in B point there is decision variables are available as like 30 comma 30, x equal to 30, y is equal to 30. Likewise we can get the solution from the solution space that are available with the graphical method in operations research, which is one of the methods that are available to find out the optimal solution in operations research method from linear programming problem. Thank you.